For today's quiz, we have two light bulbs. They're called grain of wheat light bulbs. They're just small incandescent bulbs. I have a 6-volt battery, a lantern battery. I have a switch, normally open. Comes along, I've got bulb, let's call this one bulb 2 and this one bulb 1. And they're pigtailed together, so they're going to end up getting the same voltage across them. I have everything taped in place so the wires don't move around. When I press this button, both light bulbs light up. Our question for today is, if I were to take a coil of wire and insert it in series with one of these, what would happen? And what do I mean by a coil? Coil is just that. I take wire and I can coil it together. This wire is really heavy duty and a little bit too thick to be using, but to illustrate, we can show you what a coil is. Sometimes you can even wrap it around a piece of iron or something like that to help keep the wires from fraying and so on. Instead of using that, I'm going to use a coil that's already made. Now, the coil is made of a very fine wire. It's got a little bit of resistance, so that might offer a little bit of an issue, but let's ignore that for right now. This red plastic is just to hold everything in place. It's just a very fine coil of wire, and I can end up taking it to each lead. And I'll simply insert that right into my circuit here, maybe like that. So that's our question for today. I have it illustrated here. As always, mark your answer as completely as possible and list your confidence. How confident are you about your thoughts? I'll get this set up. We have the circuit set up. I inserted this coil. I had to retape a few things. You could see this wire off of, we'll call this bulb 2, is connected to our coil. The other side goes out to the same exact negative to the battery. Typical student responses include, first of all, this second bulb, bulb 2 with the coil, it's not going to light. There's too much resistance in this wire. Now, one of the things that I'll do is I'll let them know that this is really nice copper wire and the resistance is small enough, it's not going to end up blocking current from flowing through here because of resistance. And I can even give their quizzes back after we discuss these ideas. Others will say, well, nothing different is going to happen. You have electrons going through wires and they have two paths, and if there's not a lot of resistance, they're both going to light up just as they did before. And some will say, no, one of the bulbs will be brighter. They think somehow a coil makes things brighter. And when you push on them a little bit, they don't really have a response. They've just kind of guessed that a coil will do something. And those are the typical responses that we get. Once students have given their thoughts and discussed in detail, we can press the button and see what happens. So let's keep our eyes on both of these bulbs when I press this. Did you see anything interesting? Let me get the lights and we'll do this again. Did you see it? I'll put this in slow motion so you can see. All right, I have the lights back on, and this is really unexpected. The students at first almost think that their eyes are playing tricks on them. They're like, it appears that one light bulb lights up before the other, but how can that be? They're going to end up using their models that they've already learned about electrons already being in the wires. And if I have one electron and it smacks against another electron, it's got to smack against another electron. So it doesn't matter the size of the wire. When you hit a light switch, lights turn on nearly instantaneous. But this is not what we're seeing here. That's really bizarre. So I'm going to explain this, and to do so, I'm going to use a different coil, a coil that is going to be an industrial coil, the wires are going to be a little bit thicker. There was a very, very slight difference in the bulb brightness once they were both illuminated, and that's because of this thin wire. It does have a little resistance. So I'm going to trade this out for an industrial coil. All right, I've traded out our thin wire for a much thicker coil. And it's hard to see, but there are much thicker wires here. And they are wrapped around very tightly like we had here, except now we've got a nice ferrite core. Actually, it goes around, but it works the same way. So we now have a very, very, very large coil, and the wires are going to have even less resistance. So you can see that I connected to the two tabs. I have this little alligator clip right here, and that's just holding the wire tight to the lead here. I'm going to get the lights again. And now I'll press the button again. Did you see it? Let me get that in slow-mo. All right, there's no denying there is a delay here. This is really important because we're now talking about magnetic fields, and that's what's happening. As we have wires in a coil, any wire has a magnetic field that will end up forming around that wire. But when we coil them, we get more of that effect. And if we coil them the right way, we can end up getting an effect that is really significant. You can see there's a delay. So now we have a way of making a timing mechanism using magnetic fields. So magnetic fields are going to have to grow, and they're going to take some time to grow, and that's going to lead us into a whole variety of phenomena that we'll need to discuss. But that's your quiz for today.